Hello there, algebra students. This is Mr. Kashi speaking. Today's video is our first lesson in quadratic equations. So really we're not going to be studying the equations, but we're going to be studying their graphs. Over here to the right is the graph of a quadratic equation. We're not going to talk about the equation, but we're going to just talk about the characteristics of the graphs today. And what this is called, this shape is called a parabola. There are just a handful of things that we want to be able to get down before we start talking about equations. So parts of the parabola that we want to talk about is, does it open up or down? That's one thing that we're going to be finding. Obviously, this one opens up, but we're not going to talk about the specifics here. We're going to talk more about general things. So here, the next thing is what we call x-intercepts. And that would be where the graph crosses the x-axis. And so that would be these two spots right here. And so usually, in this case, there's two x-intercepts. You could have one x-intercept, or there's also a point where you would have, there are some graphs that you'd have zero x-intercepts. And usually we write them in terms of just their coordinates of x, y, but not always like that. We'll go into some examples of why you would just say, well, a single number for each of those intercepts. So if we have x-intercepts, then we must have y-intercepts. And I should correct myself there, just y-intercept. There's only going to be one, and that's where the graph crosses the y-axis. And that's going to be right there, the y-intercept. And it's also going to be just the coordinate x, y, and there's only one. And there's always going to be one, or else it wouldn't be a function. The last couple of things here, we have two more. We have the vertex, which that is going to be the maximum or minimum point. In this case, it's the minimum point. It's right there. That's the vertex. And that's also going to be stated as x, y. And then lastly, we have what we call an axis of symmetry. And really, if you know symmetry, it means it's the same thing on the left as it is on the right. And here, this is what I would just call it as a middle line. And that would be right down this here. Just like that. Sorry, it's not very accurate, but right down there. And we're always going to have an equation, since it's going to be a vertical line for a parabola, it's always going to be x equals some number right there. So those are different parts, and today's lesson, all we're doing is going through and labeling what all of these are. Does it open up or down? The x-intercepts, the y-intercepts, the vertex, and then the axis of symmetry. So this first example, does it open up or down? And hopefully you can just see that it opens up. It's pointing up like this. Our x-intercepts would be here and here. And so that would mean that it would be -1, 0. And it would be 3, 0. Now, for x-intercepts, the y is always going to be 0. So you wouldn't necessarily need to write the whole coordinate. You could just say, well, the x-intercepts are -1 and 3. You don't have to say 0 because it's assuming, if we're talking about an x-intercept, that y is going to be 0. For our y-intercept, it would be right here. That would be the point 0, -3. Now once again, for all y-intercepts, our x is always going to be 0, so you wouldn't have to write it as a full coordinate. You could, if somebody were to say, what's the y-intercept, you could just say -3. That is not the case for the vertex. The vertex, you have to be specific. The vertex is right there, and in this case that would be 1, -4, and that would be a minimum value because it is the lowest point on our graph. And then the axis of symmetry is coming down right here, and that's going to be x equals 1, and that's a vertical line. It doesn't have a slope. The slope would be undefined. But one thing that I want to make sure that you guys know is that the x term of your vertex is always going to be the same as the equation of your axis of symmetry. Those are always going to be equal. So I do want to go over a couple of different ones, a couple of different examples. So open up or down. Well, this one opens up again, probably the easiest question that you can have. X-intercepts. Well, if you take a look here, there are none. We don't cross the x-axis at all. So we just say there are no x-intercepts. The y-intercept, though, would be right here, and that would be at 0, 3, or you could just say 3 in this case. The vertex is at that point right there, which is 0, 3. So our vertex and our y-intercept are the same thing. And then going to our axis of symmetry, our axis of symmetry is actually that y-axis itself, and that's going to be x equals 0, and once again that is the x term from our vertex. So I wanted to go through an example that didn't have any x-intercepts because that parabola might look a little different than obviously some of the other ones that we've gone through. Alright, here's another example. Does it open up or down? This opens down, this case. We're pointing downward. Our x-intercepts are here. Once again, you could say -5, 0, and 2, 0, or you could just say that the x-intercepts are -5 and 2. You wouldn't have to write out the coordinates. The y-intercept would be right there. Y-intercept would be 0, 2, or you could just state that the y-intercept is 2. You don't have to. We assume that x is 0 when we're talking about a y-intercept. The vertex is a little trickier here. Without having an equation, we're just going to put it right there. And so what I'm going to say is I believe the vertex would be -1.5, and then I believe it would be 2.5. It's not exactly that. I think it's a little lower than 2.5, but for our purposes, that's what we're going to do for right now. The problems that you do will be very clear where the vertex is, but I wanted to show kind of a different problem with a little wider parabola. And then the axis of symmetry would be coming right down the middle of that parabola, and you would just use the same x term from your vertex. And that's going to be important because once we go further, we might be going the opposite way here, where we're going to find the axis of symmetry first and then go to find the vertex. So I just want to make sure that there is a clear connection between the x term of the vertex and the axis of symmetry. And then I had one more here that I wanted to go through. Up or down? Well, this is down. They're pointing down. The x-intercepts. Now there's a parentheses around the s because sometimes you're going to have 2, sometimes you're going to have 1, sometimes you're going to have 0. Well, in this case, we just have 1. We have 2, 0. So if they were to say, what's the x-intercept, you could just say, that is 2. We only have one x-intercept in this case. The y-intercept would be 0, -4, or you could just say -4. The vertex right up there is going to be the same as our x-intercept. That is going to be 2, 0. And then the axis of symmetry coming down right in the middle, splitting it into 2 equal sides, would be x equals 2. Once again, that is the same as our x coordinate for our vertex. So hopefully this gave you plenty of examples to work off of, some pointing up, some pointing down, some that have 0 x-intercepts, some that have one x-intercept, some that have two x-intercepts. They're all going to have one y-intercept, and hopefully the different vertices and the axis symmetries helped you out. So hopefully these were helpful, and good luck on your assignment.